Hey everybody, let's go ahead and start doing our first operations on milling this little metal plate here. Just to center us, to get us all kind of on the same page here, what we have is we're going to be making this little part. This part is 1/4 of an inch thick, and it is 3.5 inches long, and it is 1.4 inches wide. The thing that is a little bit weird about this, or it might seem weird at first, and is pretty common in using CNC mills, is we're actually milling this out of a piece of material that is notably thicker than it needs to be. And the reason for that is we want a good area that the vise can grab, yet we won't run the tool into the vise. So we want the vise to hold the bottom edge of the piece of aluminum, represented by this shaded box, and the actual part that's in kind of the top half of that material. Now, it's not all of the top half. We're actually going to be machining off the very top surface too. We're going to take a 50,000th deep cut, or 0.05 inches, right off the top there, and removing that top layer. That next 1/4 inch below that, that's actually going to be our part. And that leaves us with 0.2 inches down below that will be held in the vise. I do want to also point out that right here, this little set of arrows here that say X, Y, and Z, I know they're really small there, but those establish our work coordinate system. In other words, where the center of uh, where our measurements are all being taken from. So the very center of our original block of metal, in other words, the top surface, centered in the X direction and the Y direction, that very top point there, that's what we're going to be establishing as our 0 point. So if we're looking straight down, that point right below my cursor there, that is 0, 0 in the X and Y direction. And the very top surface right here, that is actually 50 thousandths of an inch below the Z0. And so the reason for that, again, is we're going to be removing some material off that top edge. Okay, so our first operation of what we're going to be doing today is we're going to be drilling 3 holes, and these 3 holes provide access for an end mill later on. But those 3 holes are going to be right here in the middle of this slot, right here in the middle of that hole, and right here in the middle of that slot. So we're going to jump over to PathPilot, and we're going to log in. Oops, not there. We're going to go here. We're going to log in, and we're going to access the virtual PathPilot. And we click Enter PathPilot and connect. Okay, our terms and conditions are here. I'm going to click Agree. And once again, it's going to take a few seconds. There you go. This pops up. We are using a 770M Plus. And we're going to click Save and Start. Okay, so here we are in the PathPilot control. You can see the red reset button is flashing. That's always the first thing that we click. Now, the next thing that we always do is we do reference Z, then Y, then X. So those axes have referenced. I've shown you in another video a step that we're going to do right now. We will only be doing these steps when we're using the PathPilot hub, in other words, the virtual PathPilot control. I'm going to switch by right mouse clicking in this black area. I'm going to switch to the isometric view. And so that way you can see what we refer to as the fish tank. This is our build volume, or our machining volume in the machine. We are currently at this top left back corner. That's where the nose of the spindle would be right now. We want to establish a point right in the middle of this whole fish tank, very center of the fish tank, where we want it to call that point 0, 0, 0. So what we're going to do, and again, we only do this in the online version. We're going to type in a little bit of G code, and we're going to say G0, G91. That's going to put it in relative mode. X7, Y -3.75. Z negative 7.5. And when I hit enter, you'll see that it's going to show a line going from that little point that we were just looking at, that in the top back left. It's going to now take that and go right to the very center of the whole thing. That has gotten us to this exact point. I'm going to take a moment. I'm going to go down here to not the reference, but the Z0. We're going to say, hey, we're going to call that in our digital readout, that's DRO. We're going to call that 0, 0, 0. And once we're done with that, now we're going to go back to our MDI, and we're going to be clicking on G0, G90. In other words, we're going to put it back in our absolute mode. If you look down here at the bottom, our current status G54, that's our work offset that we've actually just zeroed at. And then here it says G91, which is that relative move. We want to put it back in absolute. So we hit enter now. You can verify that we are now in G90 at the very bottom. Okay, so that stuff that we just did there with moving the position around and setting it to 0, 0, 0, that's only when you're using the PathPilot Hub. You wouldn't want to do that on the machine because there might be something in your way and you would crash the machine. Okay, so here's the first operation of milling this little aluminum block. I am starting off with the F-size drill bit. This is going to be drilling 3 clearance holes. All these clearance holes are for is providing a wide open spot where the end mill can start at. It's just easier on the end mill, preserves the life of it a little bit. You can see I have everything put in here according to my work coordinate system. The drill bit is directly above that little dot right now, and I'm going to start actually plunging down and drilling this hole. I'm going to try to keep the coolant turned off so you can see what's happening, but I may have to turn it on here and there. Okay, next up, we need to put in some tool offsets. If we're doing this right, we will only need to do these tool offsets once. So I'm going to click on offsets, and we have what we call tool number 4. This is in reference to your tool spreadsheet. Here's tool number 4. I have it highlighted right here. It's a 1/4 inch end mill, and it has a 0.75 cutting length, and it has a part number of 37370. And I have some data for how fast it can cut and how deep it can cut and how wide it can cut. We're going to be referencing a lot of this information as we go, but for right now, we're just going to need to put this information into the PathPilot control. So let's go to tool number 4 here. I'm going to double click on that, and I'm going to change this to 1/4. So it's a 1/4 inch. It is a 3 flute, has a 0 corner radius. In other words, it's a square corner. And that had a length of cut of 0.75. And it is carbide, and its diameter is 0.25. And the last little bit here is that happens to be 37370. Not all that information is necessary to have on its description, but it sure is helpful. So when I hit enter, one of the things, PathPilot's kind of smart in that it recognizes some of that text. It says, wait a minute, don't you want me to change the cutting diameter to 0.25? Yeah, I sure do. So we're going to go 0.25. The other thing that we're going to need to know is we're going to need to know the length of the tool. And I measured this particular one at school the other day, and it is 3.032 inches long. And we'll press enter. One of the things that is a little bit weird with PathPilot is anytime that you do put something in a table like that, or any value in any place where you can insert a value, you can't just press tab to go to the next thing. You actually have to press enter. Okay, so I'm also going to be entering the drill bit, and if we look on our tool data sheet that we have, That tool data sheet says that, hey, tool 57 is our F drill bit, has a diameter of 0.257. It has a bunch of other information here. We're going to go ahead and put that in there. And we're only entering information right now for 2 tools. So this will not take too long. So this is an F twist drill. It is 135-degree split point, and it is titanium nitride coated. And I don't know what the part number is. I can look that up right now, but honestly, I don't really care right now. And so what I'm going to do is, oh, see, I clicked somewhere else and I lost my information. So there's a good lesson there. So this is, again, and yeah, good enough. I'm going to press enter. Don't forget to enter. And that is 0.257 inches in diameter. And its length, well, I measured that as well. And the length of that drill bit was 5.6945. Okay, so now I've entered in the offsets for those two tools. Okay, let's go to our conversational tab. Now we're actually going to be doing some drilling. So conversational is a great way to put in information on how to do simple tasks or simple milling operations. Our first thing that we're going to be doing is drilling. And if you recall, at the beginning of this video, we said, hey, we're going to be doing some drilling at 3 locations. Quick look back. Here's our little piece of metal that we're going to be drilling into, and we want a hole right in the center of this slot. We want a hole right in the center of that circle and right in the center of this slot. So remember, our work offset, our origin, is actually right here below this hand. That is 0, 0, 0, right there. So in the X and Y direction, we know the location of this one. So that's going to be really easy. That's 0, 0. But where is the center of this slot and where is the center of that slot? Well, one of the parts is easy. This is the x-axis, so the y position of the center of that slot is 0. The y position of the center of this slot is also 0. So the y position is easy. What about the x and y? Well, if we look here, we have a distance to the far end of the slot is 1.45 inches. The distance from the center to the near end of the slot is 0.67. So halfway between those two values is the center of that slot. So if I take 1.45 and I add 0.67, that is 2.12. 2.12 divided by 2 is 1.06. And we will have 1.06 for the x value in the positive direction, and we'll have 1.06 in the negative direction as well. So let's pop back over here. And where are we going to want some holes? Well, we're going to want some holes at 0, 0. That was easy. We're going to want some holes also in the x direction at 1.06, enter, 0. Again, 0 for the y. Where is that third hole? Remember, it's 1.06, however, it's in the negative direction, and 0 there. So that is actually given the location of all 3 of our holes. Moving on. Yeah, we're using that work offset G54. We're going to call this drilling. And tool number that we're using, that's going to be that drill bit, tool 57. And spindle RPM. Well, if we look in our tool table for that drill bit, tool 57 says right here 4,600 RPMs, and also it's a 0.063 peck. So it's going to just peck down at that hole about 1/16 of an inch each time. Okay, so from that table, what I'm going to be doing is I'm going to be putting in that spindle RPM of 4,600 RPMs.
Notice that the feed rate is grayed out here. That feed rate refers to an X and Y direction. We don't want to be trying to cut sideways with a drill bit, so it does not, when you're in a drilling operation, there is no movement in the X and Y direction, so that's why that's grayed out. It doesn't matter what number's there, it just is not going to happen. The Z feed rate, though, is how fast it plunges down into the material. And so you can use, I have written down a value for this of 13.5. We could even go a little bit slower, so 13.5 is fairly quick, fairly fast, but I think we'll be okay there. We do want to go over here, and I mentioned one of the things on that table was the peck depth. And pecking is shown in this little diagram. And I will say one of the things that's nice with something like PathPilot here is if you do mouse over something, it'll have little pop-ups that'll say, hey, this is what it's caused, or this is what it does. Spot tool number causes a spotting operation. And spotting is where it makes a little dimple for that drill bit to follow. We don't need to do that here, but it shows also what is referred to as a peck here, where it is drilling at multiple depths. You can imagine like a woodpecker pecking into the bark of a tree. That's a lot like what peck drilling is. And we're going to do a 0.063 inch peck. One of the things that's nice about doing a peck depth, especially with drilling, is that allows the chip that is formed to break off. It stops that continuous chip so you don't end up with metal flinging all around the place. Okay, where are we going to have it start that? Well, we're going to have it start that hole at the very top, so at 0, Z0, very top of our material. And then we're going to have it finish this off at some depth. So we've got a couple different things going on here. Z end. Well, the Z end, where is going to be the bottom of this hole? And you might look at our print and go, well, it's a 1/4 inch thick part that we're making, so maybe I want my hole to be a 1/4 inch deep. Not quite. Because remember, we have also the 0.05 inches, the 50 thou that we're removing off of the top. So we've got to add that in. So you might think, oh, well, that would be 0.3 inches deep, because that's a 1/4 plus 0.05. And still not quite, because if you look, the hole that we're drilling is measured to the tip of the drill bit. So we want to go a little bit beyond that. So what we're going to do is we're going to say we're going to make this negative, in other words, down below 0, 0.4 inches. We're going to press enter. The last thing that we need to put in here is something, I said we're not going to do a spot tool, so leave those blank up there. But Z clear, over here we need a clearance height. In other words, how high do we want this tool to retract above the material so we don't run into anything if it moves in the X or Y direction afterwards. And we certainly don't want that negative. Heck, that's deeper than we're actually making our hole. So what we actually want to do is we're going to make that 1/2 inch above our material. So in other words, 0.5 in the positive direction. I'm going to press enter. Okay. So we've done everything that we need to here. Everything looks wonderful. We're going to make 3 beautiful holes with this size F drill bit. I'm going to click Post to File. And what it's going to do is it's going to bring up these folders here. What I want you to do is I want you to get in the practice of opening virtual PathPilot files, and you're going to create your own folder in there. And this will retain your files in your own virtual environment. Any of these other folders that we see here, or anything that you save under this area here, it'll be deleted the second you log off. So you want to make sure that you are in the virtual PathPilot files. And I created a new folder by clicking New Folder. I called mine Bearing Plate, and I opened it. And I already have another one in here. We'll talk about that one later. But I'm going to now press, it's saved as drilling. I'm going to press Save. And that's going to save my drilling operation. Okay, so now we look at this screen here. This shows us what that actual operation looks like. I'm going to right mouse click here, and I'm going to say I want to see the ISO view. And that shows me with really pretty good detail what is going on here. And I'm going to zoom in a little bit so you can see. Here we have our origin, okay, X0, Y0, Z0. And so that tool is going to go and it's going to, I think we have this one actually first. It's going to drill a hole, and it's going to come up, and it's going to go over 1.06 in the positive X direction. It's going to drill a hole. It's going to come back up. It's going to shoot back over here, and it's going to drill a hole. It's going to come back up. Once it's done doing that, then this part is done. What I want you as the student to do is once you get to this point, you're like, okay, I have designed this circle. In fact, every time you do one of these toolpaths, what you're going to do is you're going to press print screen. That's the one that's up near backspace or delete up there. You're going to press print screen, and that is going to copy it. And I want you now to paste that into a Google Doc. And I'm going to paste, or just hit Control V. And that prints my screen. So now I can see that I've completed that. And so I might want to just say something at the beginning of this like drilling. And so that is done, and you'll basically be creating a record of all of your modules or all of your toolpaths that you create in these tutorials. That's it. Have a good day. See you later.